Welcome back to Working with Watson. Quick little lesson here for you today on the elements that are going to go with the periodic table. So we're going to really look at the periodic table the next couple days and the elements. So we've been talking about atoms, and atoms are the smallest, tiniest particles that make up all matter. Matter, again, has mass, takes up space. Okay, it's something physical. The atoms that make them up cannot be broken down any further, is what atom means. We saw that in the reading. The atoms are so small that if you take a millimeter, so a millimeter, like, that tiny of a, tiny space, and cut it into a million pieces, that would be one size of an atom. Okay. I also found out that if you take a human hair and you take the width of the human hair, the skinny side of the human hair, you'd have to cut it 100,000 times to get the width of an atom. So when we say small, we are talking small. Okay. So atoms are there. Elements are created by atoms depending on how many protons and neutrons and electrons are in the atom itself. Okay. If you have an atom that has one proton, one electron, and then one neutron in there also, you have hydrogen. If you have this element here, so this is a element box that you'll see on the periodic table, and this is carbon. So it gives you the element name right here underneath, carbon. It gives you its atomic symbol, which is C. Some of them do not go as well with that. That's a pretty easy one, carbon, C. Some of them are definitely different than that. It will also give you this is its atomic number. So the atomic number of 6 tells you it has 6 protons that create that atom. If you were to put more protons in, you change the element. Okay, and actually if you put one more in, it would change it to nitrogen. Nitrogen has an atomic number of 7. So on each of these boxes, you're going to see the atomic symbol. See, you'll give you the element name. It'll give you its atomic number, and that tells you again how many protons, electrons, neutrons are there. Now, neutrons can vary depending on how many are in there, based off of, because they're neutral. They're in the middle. They don't have a charge. They're just holding everything together. So sometimes you can throw in an extra neutrons, and it doesn't affect the atom at all. If you throw in extra protons, you're starting to change things. Okay. Electrons can sometimes come and go, creating ions. They get attracted to the electrons, get pulled off by other elements to create different molecules. The last thing down here is this at the bottom is its atomic mass. So again, its mass is the how much stuff makes it up. Well, in this case, 12 comes from the 6 protons that create the center, and the 6 neutrons that also make it up. They do not count the electrons in the atomic mass because electrons are so small, they're not really affecting the weight of it at all. And now when we talk about this number, is the atomic mass units. It has its own units of measure, because again, we're talking stuff that is so small. We can't measure that in milligrams or grams. A gram is the weight of a paperclip here. So we can't measure a single piece of an atom that is 1/1,000,000th of a millimeter in the same scale. So they have their own scale. It's AMU. It's atomic mass units. But that is what this number is. We're really not going to work with this number much, but I did want to tell you what it was. So another example of this is this box here. So here's hydrogen. It looks a little bit different. The only difference is this number, instead of being at the bottom this time, is up here in the corner. So depending on the periodic table you see, it may look a little bit different. I just kind of wanted to show you that one. So again, hydrogen has its atomic symbol as H, gives you the element name, hydrogen. It gives you its atomic number as 1. It means it has 1 proton, 1 electron, 1 neutron, usually, and then its atomic number here is 1. So in this case, it may be more of one proton. Maybe it doesn't have a neutron, just has that electron floating around the outside. So I wanted to mention those boxes just to give you an idea, because what we're going to go to today is I have this link posted down or in Classroom, and it will say interactive periodic table. When you click on this, here is the actual periodic table. All right, so you have hydrogen here, which has 1. It actually jumps way over here next to helium is 2. Then it comes back over here to lithium for 3, beryllium, boron, carbon, and then it continues to go up side to side. You go all the way down to the end, all the way down each time, and then you can get up to here's 98 is the highest they have listed. They do not, I should say 98 is the highest picture one they have, but our elements actually go up to 118. They don't have a lot of the pictures and the usages of it for here. So what I want you to kind of look at today is I want you to pick 15 of the different elements to look at here first. So you might say, okay, I'm going to check out carbon. So when you click on carbon, it pops up and changes this. So it says carbon is basis of life's molecules. So it will tell you carbon is can create hard diamonds, soft graphite, graphite's the lead in a pencil, basis of life's organic molecules, animals, plants, CO2 is carbon dioxide, wood, paper, cloth, plastic, coal, oil, and gasoline all have carbon in them. So let's say I want to go to iron down here. Iron is created in steel structures. It's a medium hard metal. It's magnetic. It has steel alloys, are mostly iron structures. It creates vehicles, magnets, Earth's core, red rocks, and blood. So there's iron and blood. Okay. So again, you're not going to maybe know what every single thing it tells you in this little box is. That's all right, but you can still get an idea then about what some of these elements do. And I said, just to kind of see what is out there and what is being used on different things, just to kind of get used to it. Also, again, make sure to check out the atomic symbol. So iron atomic symbol is actually Fe. Okay, we're going back to way into the past, and original names of some of the elements were said in your ancient Greek or Latin, and those words were there. The atomic symbol was created based off that. The atomic symbol for iron is 26. Okay. So once you are done on going through, I said 10 to 15-ish, just check some of them out and see what different ones look like. I think it's interesting to go through. And this is the one, you should have seen this from Monday or Tuesday. But I want you to check this out. So here is the atom one where you clicked on it to create an atom. So you created, and maybe you said, okay, here's my hydrogen. Boom. Oh, maybe if I get a neutron there. There's my hydrogen. And you can see we have the H on the periodic table. It's number 1. If we go back here, H, hydrogen, number 1 right there. The other thing that you could start to do this time is you could go to here, and you could see when you build the atom, what does it show here for the symbol. So I'm going to say, okay, I'm going to not do hydrogen. I'm going to do 3 of them. So I'm going to create lithium. Notice in my box here lithium is Li, atomic symbol. And here is my atomic number. It's down here at the bottom this time. I don't really love that they put that there, honestly. To me, it should go here because it's the most important one, but that's how they did it. So it has this. The positive 3 is because I haven't added any electrons yet. If I add my electrons like I have to have, now I have a 0 charge, and we want a 0 charge. But again, my atomic mass is 6. I have lithium, and the 3 is my error. You can kind of see some of those if you want to mess with it. And then the other part is you can go to the game, And this time you could get into messing with the periodic table here, or the periodic table in here, or take a gamble and hit the question mark and see what it comes up with and see what you find. So this time you have to count how many are there and say, okay, my atomic number, well, there's 2 protons. There's 1 neutron with that, so my atomic number should be 3 because there's 3 things here in the nucleus. And my charge should be 0 because I have 2 protons, I have 2 electrons. Those should cancel each other out. Oops, nope, 0. And if we check, we're good to go. Okay, so that is what said. Once you kind of go through the periodic table today after you watch this video, I want you to know list me at least 2 elements in the comments. So when you're done, list me 2 elements that you found out about and tell me what you learned that those elements are in below. So, and when you go to go back to classroom, at the bottom of those comments, comment in there and tell me what you learned that is, what some of these elements create or where they're found. Peace.